In this video, we will see dry run of the code. So now let's quickly check out the dry run of this code. Okay. So this is my reverse function, right? Helper function. So we will start executing our code from this line. So first of all, we need to find the middle node of the linked list, right? So I will take one slow pointer. Let's suppose this is my slow pointer. One is fast pointer. Fast is pointing to head and slow both are pointing to head. Now fast is not equals to null and fast dot next is not equals to null. I will run slow and fast by 2 steps. Fast will move with 2 steps, slow will move with 1 step, right? So after one iteration, my fast will be here and my slow will be here, right? Again, after one iteration, my slow will be here, my fast will be here. Okay. After one iteration, my slow will be here and my fast will be here. Okay. After one more iteration, my fast, but let's see. Fast dot next is equals to null. Yes, it is. So it will terminate here because your fast dot next is equals to null, right? It will only run when fast dot next is not equals to null. So my slow pointer is pointing to this middle node and this is the middle node, right? So I will remove all these things. Okay, not the slow one. So basically my slow pointer is pointing to this node. Now, once I get this node, now I will reverse half of the linked list, right? And I will get tail of the reverse slow. So basically, once I passed this slow in my reverse function, what it will do? It will break these connection, right? It will break these connection one by one, right? So this 4 will point to null, okay? And this 5 will point to 4. Then this 6 will point to 5. And then this 7 will point to 6 and you will get 7 as a tail, right? So the clear diagram will be look like this. Yes. So we have done this step, right? Now my current will point to head. So here is my current. Okay. And this is my tail, right? And now let's modify the linked list, right? So while tail dot next is not equals to null. So tail dot, so let's start. So temp is pointing to current dot next. So this is my temp. Let's make it, this is my temp. Okay. I'm denoting with T just for removing the confusions. Tail next will be tail dot next. So what is your tail dot next? This one. So your tail next will be this one. T and I am representing it. Now current dot next will be tail. So current dot next, this will be tail, right? This one. And tail dot next will be temp. So tail dot next will be this temp, right? So let me tell you how the figure will be. One will point to tail, that is 7, and 7 will point to 2. Okay, and then current will be point to temp. So current will come here and your tail will come to tail next. See, tail will come to tail next here, right? So see, right, tail dot next is this, so it can't move in this direction, but it will come to here. Now again, temp will be current next, current dot next. So what is current dot next? This, so temp will be here, and tail next will be tail dot next. So what is tail dot next? This is your tail dot next. Again, current dot next equals to tail. So again, current dot next equals to this tail, and tail dot next equals to this temp, right? So if I create here, current dot next equals to 6 and 6 dot next equals to 3. And after this again, your current will move to from here to here, temp, and your tail will move to tail next. And after this, before starting, temp will be current dot next, so temp will be moved here, and tail next will be tail dot next, so tail next will be here. Again, your tail dot next is not equals to null. No, your tail is here, tail dot next is not equals to null, right? So again this loop will run, right? And current dot next equals to tail, current dot next, like this is current, equals to tail, where it is tail, 3 is pointing to 5 and 5 will pointing to temp, that is here. So 3 is pointing to 5 and 5 is pointing to 4. right? And now once this is done, again your current equals to temp, so your current will be here. Okay, let me create it with white pen only. Current will be here and your tail will be tail next, so tail will be here. Now is your tail dot next is not equals to null? Tail dot next 4 dot next is null. Yes, my 4 is pointing to null. So yes, this is the end of the loop. Okay, I won't do anything, and this is my modified linked list, right? 1 is pointing to 7, 7 is pointing to 2, 6, 3, 5, 4. This is my reordered list, order linked list. Okay, again, what will the time complexity here? So this loop will take n by 2 iterations, right? This is reversing will also take n by 2 iterations, and this will also nearly take, again, all these are, right, nearly n by 2, right? There can be here plus minus 1, but yeah, nearly n by 2 iterations. So the total time complexity will be order of n, that is big O of n, and representing the node. Let me use small n only. And we are not taking any space, so space complexity will be big O of 1. Okay, this will be time and space complexity of your approach. This is how you can solve this problem.